Assalamu alaikum. Today's topic is ionization techniques in mass spectrometry. We had already discussed that in a spectrometer there is a sample inlet, and the sample is introduced from the sample inlet into the ionization chamber where the molecules gets ionized. Now there are different techniques which are used for the purpose of ionization, and these techniques are: number 1, electron ionization denoted by EI, chemical ionization technique denoted by CI, desorption ionization, and fourth is electrospray ionization, ESPI. We will discuss one by one all of them. The first technique is known as electron ionization technique. In this technique, the arrangement is as shown below. It is the ionization chamber. Here we have the sample inlet. From the sample inlet, the sample is introduced into the ionization chamber. From the sample inlet, the sample is introduced into the ionization chamber. In the ionization chamber, there is a filament. It is the filament. On the other side of the tube, there is an anode or a positive plate which acts as anode. It is anode. There is also a vacuum pump attached in this region. Here is the vacuum pump to pump. Now in the ionization chamber, there is a heating filament which is electrically heated to several thousand degrees Celsius. The molecular beam is introduced into the chamber. The filament is heated to several thousand Celsius so that electrons are ejected from the filament, and these electrons move towards the positive plate or anode, which is acting as anode. During their movement from the filament towards the anode, they strike with the beam of molecules which has been introduced to the sample inlet. These electrons collide with the molecular beam and eject electrons from the molecules, producing molecular ions. Now, in this case, the molecular ions are produced. These are produced by the ionization of molecules. As electrons are hitting the molecules and they are causing ionization of the molecules, therefore this type of ionization is known as electron ionization. Now the minimum energy which is required to ionize a sample, ionize a molecule, is known as ionization energy. For most of the organic molecules, the ionization energy is in the range of 5 to 8 electron volt. If the electrons which are produced from the filament, if they have less energy, then they will not cause efficient ionization of the molecules. For efficient ionization of molecules, the energy of electrons hitting electrons or bombarding electrons must be from 50 to 70 electron volts. If the energy of electrons which are produced by the filament is from 50 to 70 electron volt, then they will cause the efficient ionization of the molecules. Now once the ions are produced, they are directed towards the accelerating plates A and B. A and B are the accelerating plates having a potential difference of 1 to 10 kilovolt. No, the molecular ions, positive molecular ions are cations which are produced by the bombardment of electron beam with the molecules. They are directed towards the accelerating plates by means of repeller plates which are positively charged. Now these repeller plates, they direct the molecular ions towards the accelerating plates. There is a potential difference of 1 to 10 kilovolt between the accelerating plates, so the molecular ions are accelerated between these plates. Then there is a third plate which has slits in it, and these are known as focusing slits. Now the ions, molecular ions which have been accelerated by the accelerating plates and directed by the slits, they move into the uniform magnetic field. Molecular ion beam is introduced into the magnetic field where they are separated and detected later on. Now this technique has two advantages. The advantages of this technique are that number one, it is the hardware of the technique is inexpensive. It's cheaper. Secondly, light organic molecules can be easily studied through this technique. And number three, a huge amount of spectral data is available in spectral libraries. Huge spectral data is available in spectral libraries for purpose of comparison and determination of molecular weight. These are the three advantages of electron ionization technique: that the hardware is inexpensive or cheaper, light organic molecules can easily be ionized in this technique and they can be studied, and third is that huge spectral data is available in spectral libraries for the purpose of comparison and determination of molecular weight. There are few drawbacks of this method also. The drawbacks are, at number one, this technique is applicable for light molecules. It is most suitable for studying lighter molecules, lighter or volatile molecules, and is not good for heavy molecules or biomolecules like proteins or carbohydrates, etc. And secondly, in this technique, the molecules may undergo a rapid fragmentation process, and this fragmentation of the molecules will be so rapid that we cannot determine the exact molecular weight of the light molecules. The fragmentation of original molecules may be very rapid, so that we cannot determine the correct molecular weight of compounds with precision. Now during this process of ionization, the molecules, some of the molecules gets ionized, but most of the molecules, they remain unionized. They cannot be ionized, and these unionized molecules, they are constantly taken out by means of vacuum pump. There is another possibility that the electrons which are produced by the ionization of molecules in the ionization chamber may be caught by some other molecules, and we may also get negatively charged ions or molecular anions. Now to study the molecular mass of these anions, we change the polarity of the accelerating plates as well as the repeller plates. In that case, when we have negative molecular ions, the repeller plates are made negatively charged and the accelerating plates are made positively charged. so that the same process will occur. The negative molecular ions, they will be accelerated by the positive plates and then they will be deflected by the magnetic field.